again discuss? Yeah, if you have any question, just let me know. Otherwise, I will go ahead. So I was discussing this. Am I right? E plus S, yes, giving you product, and then it can, one inhibitor can bind to E to give EI. Inhibitor can bind to ES to give ESI, and there is also EI plus S to give you ESI. So all probable scenario is included in this. This is the general general scheme for inhibition. And if that is the case, then how to go and get the Lineweaver-Burke equation in presence of in presence of inhibitor. That is the question. And the way we do is E. So let me write again, E plus S ES, and then here you have EI, and then ESI, and then okay, and then this goes to product, and this is K2, suppose. So we write dP by dt is equal to K2 into ES. Am I right? And the way we calculate this kind of complex scheme is just take E naught multiply by E naught, which is total enzyme, divide by E naught. Okay. So K2 into E naught, which is Vmax, we all know this, and into ES by E naught is called fraction of ES. Fraction of ES. Okay. So basically you have to calculate fraction of ES, and then you can express dP by dt, which is your V. Let us write V. Okay. So if we can do that, it is very easy to know rate of reaction, and then do 1 by V. So this is V max into FES. So please keep this thing in mind. So we need to, if you remember Lineweaver-Burke equation, it has V, it has V max. Only thing it doesn't have is FES. Okay, so let us go and calculate FES. So here again I will write this scheme so that you know that. Yes, EI, ESI, and this is your, and this is P, this is K2. And now I have to calculate FES. What is FES? Is equal to ES divided by what are the things? E plus ES plus EI plus ESI. So this is total E naught. Am I right? E naught is either in free form of E or complexed with S, complexed with I, complex with S and I both. So E, EI, ESI, and ES. So what I will do that I will calculate 1 by FES. So it is basically E by ES by ES plus uh, 1 plus EI by ES by ES plus ESI by ES.
So here also product concentration is assumed as less.
What?
Here also product.
Yes, certainly. In every case, we are assuming same thing. Okay. So this is 1 by FES is this thing. And now, now this you have to express in terms of, so E by ES. So let us see what is, so again dissociation constant. So we will take K ES equilibrium constant. This is equilibrium constant, dissociation equilibrium constant. Let's put in that way. KEI, KESI, KESI. Am I right? So, okay, so E by ES, what we will write? So, let us see E by ES. So, KES is equal to, it is dissociation constant, means ES going to E into S. So, E into S by ES. So, E by ES is E by ES is equal to your E by ES is KES by S. So, this is one. And then this one is done. This one is done. Now, KEI and ES. Okay. So, let us first go here. KES IES. Am I right? So let's write KESI is equal to. So this term now I am looking at. This I have already done, and KESI. So what I will write? ES into I by ESI. Remember again, this is dissociation constant. So ES by ESI by ES will be. Can you tell me? ESI by ES. What will be?
I by K.
I by K ESI. Okay, so please remember this. These two terms are done. Now left is EI by ES. Okay, so EI by ES, you have to find out. This can also be written as EI into S by ESI. Right? Or you can simply write, just leave it. Okay, you have a KEI also. Yeah. So what is KEI? KEI is equal to E into I by EI. Am I right? So I have to calculate EI by ES. So can I do that? How I can do that? Here is ES, here is EI. So ES by EI is, so ES by EI is, so let's write KES by KEI is equal to क्या होगा बताओ? KES by EI is E into S, E into S by KES, sorry, yeah, by ES into, this is KES and KEI is here. So divide by EI, E into I by EI. Is this okay?
Yes, sir.
क्या क्या cancel हो गया?
E cancel.
Cancel. Am I right? And what is left? EI by ES. So what will be the EI by ES? So here you write EI by ES will be equal to
KES
KES by KEI
into I by S.
into I by S. I by S. Okay. So now you see, you have this thing KES by S. For this you have got, for this you have got, and for this you have got. And now you can calculate what will be the thing. So let us go. So here I can write simply. So let me write here only. So E by ES is KES by S. Am I right? Plus 1 plus EI by ES is KES by KEI into I by S. Okay, and plus what? I by KESI. Is this okay? So these are the 4 terms, and now you see these are the 2 terms which has 1 by S term. Okay, and these 2 are different terms. So this has 2 combination, 1 plus I by KESI, and then you can take 1 by you know 1 KES by S common, KES by S common. You see here with this term, then I will get 1 plus I by KEI. Is this okay? Okay, so let us see. If you do that, what you will get is this thing. देख लो यही है ना, 1 plus I by K ESI plus 1 by S. KES you can take outside also. So KES by S, 1 plus I by KEI. Is this okay? Anyone, if they have confusion, tell me. I can go back and show you. Let us see here. 1 plus I by KESI. So these 2 terms, second and fourth term. And then I took 1 by S common, or KES by S you can take common. Then it will be 1 plus I by S. Okay. 1 plus I by KEI, because S has been taken common. So so I by KEI, and that's what is here. So if you take KES out, then 1 plus I by KEI. Okay, and what was the V? So V max into FES. If you remember, then 1 by V is equal to 1 by V max by 1 by fraction of ES. Fraction of ES we have already calculated. This is this thing. So 1 by V is equal to 1 by V max into this equation. Okay, this equation. And then you can see that we can again plot 1 by V versus 1 by S. Right? And it will be a straight line with Now you can see here that it is KESI by S 1 plus I by KEI. Okay, so this is the whole equation. If you remember that Lineweaver-Burke equation, that was 1 by V is equal to 1 by V max, and then this was 1 plus your Km. In place of this, there was Km by S, and this is 1 plus simply Km by S. Okay, so that was the thing. So this is your equation. So you see that what we did here, we applied pre-equilibrium concept, and that's why pre-equilibrium concept is very important, particularly in enzyme kinetics. And that's why I discussed when I was discussing different what is that called, different elementary reactions. Right? We discussed conjugative reaction, we discussed parallel reaction, and we discussed reversible reaction. And after that, I discussed pre-equilibrium concept. Pre-equilibrium concept particularly important in enzyme kinetics. Okay, I will show a few more cases, but then I can show only 1-2 more cases because now I am exceeding my time limit. Okay, is it okay? Any question here?
Sir, it should be KES now in the last step.
Yeah, yes, am I right? Yeah, you are right. And this is Km basically. Is it okay? It should be KES, am I right?
Yes.
Yeah, you are right. KES, and that will be Km. If you remember, Km is dissociation constant of ES. You are right. This should not be here. Is this okay now? Anyone have any questions? Now you see, now I am going to tell you importance of this equation and how to get mechanism through kinetics. Okay. But if you have any question, just ask me, derivation part. And now you can see that I can plot 1 by V versus 1 by S, and it will be a straight line. The way we got in Lineweaver-Burke equation in absence of inhibitor. Is this okay? So let me go ahead and do. So this was the general equation. Now I am going to talk about how to get, once I have derived this, how to get the mechanism. Okay. Okay, can you see the slides?
Yes, sir.
Okay, so remember this was the analyzing kinetic data using Lineweaver-Burke equation. Double reciprocal plot, it means 1 by V versus 1 by S. If you remember, this was a straight line, intercept was given by 1 by V max, and slope is given by Km by plus V max. And this was the equation which I was talking about when there is no substrate. I plot 1 by V versus 1 by V max, and I got this. Sorry, 1 by V versus 1 by S. This will be slope and this will be intercept. Am I right? And then, okay, so this was the different thing. Anyway, this I have already discussed about this thing, so I'm not. Okay, so now let us think about what different mechanism can we think of. So this is simply enzyme, this blue one, and this red one is the substrate. So if there is no inhibition, so it goes and binds to its active site, and there is no inhibition in that case. If suppose I add inhibitor, this is I, then what will happen? That if it is a competitive inhibition, what does that mean? That it goes and binds to the active site and removes this substrate from here. So there is a competition between enzyme and substrate, and in that case, what we say that it is a competitive inhibition. Now, the second case can happen that what it does that both binds, but it doesn't bind to active site inhibitor. This is inhibitor, this is substrate. Then inhibitor doesn't bind to active site, but it binds to somewhere else, such that it changes the this pocket of active site, and so that there is a weak means this interaction between substrate and protein decreases. Okay, and that's how it inhibits. So this is called non-competitive inhibition. Okay, this is called non-competitive inhibition. Now, second thing is that there is another kind of mechanism. These are the general seen inhibition in case of enzyme, and these are the inhibitors. Inhibitors also act as a drug molecule, and so it is very important to understand the mechanism. So the last one, that is known as uncompetitive inhibition. So competitive, non-competitive, uncompetitive. It is like SN1, SN2, SNI mechanism, if you remember that. So here what happens, that first substrate binds, okay, and then this inhibitor comes and it binds to site other than active site, and then there is an inhibition here, again binding affinity decrease. So what is the difference between three is that in this competitive inhibition, ESI will not form. Means Either EI can form or ES can form. There is no time at which both I and S is binding with the enzyme. Okay, both I and S can never bind at the same time with the enzyme. So please keep that in mind. That is called competitive inhibition. Mathematically, what I can say, KESI will be infinity. So dissociation constant of ESI is infinity. It means this ESI complex doesn't exist. Okay. Non-competitive inhibition, both can exist. EI can exist, ES can exist, and ESI can exist. All three can exist. Okay. So that is non-competitive inhibition. Now, third case, uncompetitive. Inhibitor only binds when there is a substrate binding to enzyme. I cannot bind itself. It means EI will not exist. And that means KEI will be infinity. KEI will be infinity. Okay. So these two cases, one case KESI is infinity, another case KEI is infinity. In this case, no equilibrium, no dissociation constant will be equal to infinity. So that is the three different cases of inhibition. Now, can I find out from kinetic data by measuring substrate, rate of reaction as a function of substrate? Yes, we can do that. And that's why these derivations are important. Again, I showed you that E plus S ES, this we have already done. KES, this KEI, this is also reversible. So KESI, so this is KESI. So this is whole thing. And what we got is 1 by V is equal to 1 by V max, 1 plus I by KESI plus KES or KM you can write by V max, 1 plus I by KEI, 1 by S. Okay. So please keep that thing in mind. So this is the equation. You can also write V max by V is equal to this plus this. Is this okay? This equation we have already derived it. Now let us discuss one by one. What will happen if we have competitive inhibition? I just told that competitive inhibition KESI is infinity. So if you go back, KESI is infinity, this term will be 0. And so we have 1 by V is equal to 1 by V max plus KES by V max. So that's what you get here. 1 by V is equal to 1 by V max plus 1 by KES, this plus 1 by S. So 1 by V will be, if I plot 1 by V versus 1 by S, what I got is 1 by V max as intercept and this as a slope. And if you remember this equation, what was that? In absence of inhibitor, it was 1 by V max plus Km or Kes by V max 1 by S. So that was the equation in absence of inhibitor. Okay. So if I plot these two, what I get, we look at the rate of reaction in absence of inhibitor and rate of reaction in presence of inhibitor. And then I plot 1 by V versus 1 by S. What will happen in both cases, intercept will be same. So you see here. So this is in, this black one is without inhibitor and this is with I. Okay, and you see here they match. It means that intercept is same but slope is different. And once you know that this is the case, then you know that you are dealing with competitive inhibition. Only thing you need to do, you need to plot 1 by V versus 1 by S. Okay, now see this case, non-competitive inhibition, at which there is no dissociation constant is equal to infinity. Here we have taken one special case, but it doesn't matter. And you can see that in this case, both intercept and uh, slope will change. Okay, so when you see that both intercept and slope changes with respect to 1 by V versus 1 by S carried out in absence of inhibitor, then you know that you are dealing with non-competitive inhibition. Okay, this is a special case when KESI is equal to KEI, then this x-intercept will be same, and that you can find out. Okay, but this is a special case. You may not get always this, but what is the main important thing to keep in mind, that if both slope and intercept changes, we are dealing with non-competitive inhibition. And now the last one is this case. Okay, uncompetitive inhibition. In that case, KEI is equal to infinity. And when KEI is infinity, then you say this the intercept will change, but slope will not change. If I plot 1 by V versus 1 by S. And you can see here, this is a kind of parallel, but now you see that intercept is changing. This is the beauty of kinetics in determining the mechanism. You're just measuring rate versus substrate concentration, and if you plot 1 by V versus 1 by S, you will be able to know whether inhibition going through competitive, uncompetitive, and non-competitive. Okay, and that's why I say that one of the most important application of kinetics is to understand the mechanism of the reaction. Okay, understand the mechanism of reaction. Any question here? Is it clear? Aditya? Aditya?
Yes, sir.
Yeah. Arunima?
Yes, sir.
Okay. So please keep that thing in mind. Am I right? And if anyone has any question, just ask. Otherwise, I will go ahead. Okay, no question, then let's go ahead. Okay, so now what I am going to tell you, this we have already discussed, that how to get this. Only thing you need to keep in mind always that we have to convert this into this equation, V is equal to Vmax by FES. Okay, if we do that, then we will be able to calculate very easily this rate of reaction. I am going to show two different cases, and that will tell you importance of pre-equilibrium concept and how to get rate of reaction. Okay, V. So let us think about this case, two substrate reaction, uh, where E is, so there are two substrates, like we have till now discussed one substrate. So suppose there is two substrate A and B, and then this is the reaction, A giving you EA, E giving you EB, and either EA reacts with B to give EAB, or EB reacts with A to give EAB. And then finally from EAB, product is formed with the rate constant K, or K2 you can write. Again, how to get rate of reaction? V is equal to K. We know dP by dt is equal to K into EAB. Take this, multiply this by E naught, divide by E naught, and then this is V, K into E naught is Vmax, and EA by E naught is fraction of EAB. Now what I just need to do that I have to derive this FEAB in terms of dissociation constant. You can take KEA, KEB, EB, KEAB, and then so based on that you have to calculate. So let us go. I will just let you know, you can do yourself. Please try once yourself, then you can understand the this thing. So fraction of EAB is EAB by E plus EA plus EB plus EAB. Again, product we are neglecting. Okay. So 1 by FEAB will be E by EAB plus EA by EAB plus EB by EAB plus 1. Now KMA, so this is again Michaelis-Menten dissociation constant of A. You can write Ka simply, but just to show in the terms of Km, I'm just writing this KMA E. It will just come after 10 minutes, 10-15 minutes. Okay. So 1 by FEAB is equal to his here. Yes. So 1 by FEAB is equal to this. Okay. So KMA is E into A by EA. KMB is E into B by EB. So, and just take EAB will be EA into B by EAB or EB into A by EAB, anyone. Okay. So this I am taking as K, where K basically tells you about dissociation constant of EAB to EA or to EB. Both I am taking as equal. Okay. So KMA into K is equal to, so this K into KMA is equal to E into A by B by EAB. Now I can calculate E by EAB, I can calculate EA by EAB, and then I can calculate EB by EBA, and this is the equation. KMA into K by A into B, EA by EAB is equal to K by B, and EB by EBA is equal to K by A. Okay. And then from that I can calculate this thing. 1 by FEAB, KMA into K by A into B plus K by B plus K by A plus 1. And same way I can calculate it. So it is not very difficult to do these things. Okay, so this is your equation. V is equal to Vmax into A into AB, B KMA into K plus K into B plus K into A plus A into B. Okay, just अपने से करके देखना, and I'm sure that it is very easy to derive. Okay, please keep in mind that K is dissociation constant, and once you know the dissociation constant, now again you can write Lineweaver-Burke kind of plot, but this is the V. So thing is that you can get the value of rate of reaction in terms of Vmax and concentration of substrates. Okay. So this is one of the example. The next example, effect of pH. Okay, effect of pH on the rate of reaction. Again, enzyme catalysis I am talking about. So we all know that enzyme exists in 3 different forms. Am I right or not? ये पढ़ा है या नहीं? Hello, can anyone tell?
नहीं.
Yes. कभी पढ़ा था या नहीं कि पढ़ा था? Enzyme exists in 3 different forms.
So on the basis of what?
On the basis of pH. Yeah. Okay. So for example, yeah. So if you remember the protein, how do they exist? There is amine group here and COH group. Okay. This is called carbon terminal. This is N terminal. Okay, because it is a polymer of alpha amino acid. Am I right? Okay. So if you go to acidic form, what will happen? That both these carboxyl group and NH2 group will be in the protonated state. in between, this will lose H plus ion, and in the basic thing, this will also be lost. All right, so
So
three
can't
different,
it be in a Zwitterion form?
yeah, Jupiter ion form you can say, yeah,
So
it
that will
can
be
be in
different.
Jupiter, yeah, it can be in Jupiter ion form also. Okay, so so here what we are showing in acidic form, it is like NH3 plus COH, and then this form it will have deuterionic form. You can take like this also. This you can represent at EH. So same thing, because charge is not here in the deuterionic form, minus and plus, so it doesn't matter. So here we can write like that. So this you can take as a deuterionic form, and the last is in the basic form. Okay. So this is kind of neutral pH. This is in basic pH, and this is in acidic pH. So this in deuterionic form, or this form, you can write this as EH. And then when this H is lost, then you have a basic form. So this is E. And then in acidic, you have EH2. Okay. So this is the way I'm representing this. So, and the equilibrium constant this between this is given Ka, and this is Kb. Okay. Now, okay, so this is equilibrium. Here EH is binding. Here I assume that EH is, so neutral form is binding to S to give you EHS, and then EHS gives you EH plus product. Okay. Again, this EHS can exist in two different form, ES2S, ES. So if this is the mechanism, suppose, then how I will look at the effect of pH. Okay. So that is the thing. So how I will go ahead? If you remember, V is equal to, let's take this is K2. So what I will write? V is equal to K2 into EHS. Am I right? And then what I will do? Multiply by E naught, divide by E naught. So what I need to calculate is fraction of EHS. If I can calculate fraction of EHS, then I can see the effect of H plus ion, pH. So that's what has been done, K into EHS, and then multiply by E naught, divide by E naught, and then what you will get is Vmax into FEHS. Okay. And then if you calculate this, you will find that V is equal to K2 into E naught into S by Km 1 plus Ka by H plus H plus by Kb plus S 1 plus Ka dash by H plus H plus by Kb dash. So this is the equation which you are going to get. Same way you have to do. Km is again dissociation constant of Es. Okay. So please keep that thing in mind. And then other constants we have already defined. What is that? Now let's think of, if substrate concentration is low, then I can neglect this. Am I right? So what I get, V is equal to K2 into E naught into S by Km 1 plus Ka by H plus H plus by Kb. Now that's what I am going to write. V is equal to K2 into E naught into S, Km 1 plus Ka by H plus H plus by Kb. What will happen at low pH? At low pH, H plus will be high, and so these things can be neglected, right? These two terms can be neglected. What you left with is H plus by Kb, because H plus concentration is high. So what I will get, V is equal to K2 into Kb. This Kb goes up into E naught into S Km by H plus. Okay, at low pH. So this all things are, if you look at this thing, if you take everything, this is constant, and let's take this equal to K. So simply you have K by H plus. V is equal to K by H plus, and log V is equal to log K plus pH. Okay, log K plus pH. So if I plot log V versus pH, there will be there will be increased with the slope equal to log K. So this is what you are seeing in the low pH range. Okay, so log V versus pH, if I plot, I will get a straight line with the slope equal to log K. Now at high pH, what will happen? At high pH, H+ concentration is low. It means you can neglect this term and this term. So H+ will come up. Okay, and then what we will get? V is equal to K2 E naught into S. This H+ come up into Km into K. And this is another constant here. So if I plot log V is equal to log K minus pH. In this case it will plus pH. In this case it will be minus pH. So at high pH it will go down. All right, it will go down. Okay. At intermediate pH, what will happen? These two you can neglect, and what you left is only one. In that case, V is equal to K2 E naught into S by Km. K2 E naught into S by Km. Okay. Now I can also get this point just by equating these two. If I equate these two, K2 KB E naught into S by Km H plus is equal to K2 E naught into S by Km. This K2 E naught S Km cancels out. What is left is KB is equal to H plus, or KB by H plus equal to 1. So KB is equal to H plus, so H plus is equal to KB, so this point is given, H plus is equal to KB. Similarly, if I just equate these two, then I will get H plus is equal to K. So in fact, I will be just by looking at log V versus pH, I can know what is the value of KB and what is the value of K. This is one of the very good method to calculate K. Just by looking at log V versus pH, I can know the value of KB and Ka. Is it clear? Any question here? ये समझ में आ रहा है या नहीं? It is quite easy. What I will do that try this, because ये एक बार try करना खुद करने का. Okay, in the next class I will discuss this. Please note it down. ये तुम देख लो what scheme I am proposing, and then how to get the rate of reaction I have already told. But why not you practice it and see whether you are going to get this equation or not. Okay, ये equation हो जाएगा, then you can easily able to tell how V changes with pH. Okay, and this I have already shown you how V changes with pH, and this is certainly at the low substrate concentration. So substrate part you have to remove, and then you can get this thing. And this also helps you in getting K and K. So this is all about enzyme kinetics. There are a lot of things to discuss, but I think that I have discussed enough cases, and you can come across different schemes. And please proceed using pre-equilibrium concept. That is very important concept, particularly in kinetics. And you can see that even for complex equations, complex scheme, I can calculate what is the rate of reaction. Okay. Any questions?
Sir, in case of two substrates, in slide number 5,
Yeah.
whether you have taken KMA and KMB, then both are equal. Are they equal?
KEA and KEB are not equal.
slide 5.
You are talking about this EA to this thing,
Yes.
this two. Yeah,
It
here I
indicates
have
that
taken equal. I have taken equal, but you can take different also. Then there will be a different equation. In this
usually
case,
work out.
I have taken this as equal. Is it okay?
Yes.
Yeah. What happens if I don't take equal? I take one very large, then it will go like this. Only E to EB and then EAB, then A will come up and then just to take means a complex thing, we have taken this equal. Okay. But you can get, if there is a small difference, then you can get both the cases. You can discuss both cases. Okay. Anything else? Someone want to ask? Is it clear? Isn't it easy to derive if you apply pre-equilibrium concept? Arunima, what do you think?
Yes, sir. So I'll derive one time after
हाँ,
class.
ये सारा जो 2-3 केसेस मैं बोलता हूँ जस्ट derive it.
Yes, sir.
तो प्लीज प्रैक्टिस वन टाइम. जस्ट कोई स्लाइड नहीं लो और स्लाइड नहीं देखो, अपने से डेराइव करने का ट्राई करो. देन यू जस्ट चेक वेदर यू आर एबल टू डेराइव इट और नॉट. ठीक है, बिकॉज दिस इज वेरी इंपॉर्टेंट. इसी तरह मैंने मैकेनिज्म में भी यही चीज बोला था कि यू शुड जो भी मैंने डेराइव किया एक बार लो रेट ऑफ रिएक्शन एंड देन ट्राई टू डेराइव इट. In fact, you can try few of the already take some mechanism from some book and you can try to derive जिसका rate of reaction certainly तुम्हें मालूम है, and then you can try to derive yourself. Think about that. But please keep this thing in mind that I'm not saying that we will be able to derive everything just by kinetics. Okay, but certainly it helps us a lot in knowing the mechanism.
लास्ट में हमने वो जो पीएच वाले को इक्वेट किया था और जो हम लोग को वो ग्राफ मिला था जिसमें हम के वी और के की वैल्यू ढूंढ पाए थे, उसमें हमने जो रेट कांस्टेंट है उस दोनों को इक्वेट किया था ना. जो रेट कांस्टेंट हमें स्पेसिफिक केस के लिए मिला उसको इक्वेट किया था के टू इंटू ई इंटू एस बाई के एम से. तो जो रेट कांस्टेंट की वैल्यू है के टू बाई के एम इंटू ई इंटू एस, ये हर बार ट्रू रहती है क्या? बिकॉज या फिर के कैटल
अभी वाले केस में तुम डिस्कस कर रहे हो या कोई दूसरा?
पीएच वाले में जो
पीएच. ओके, लेट्स गो. यस, तो मैंने क्या कहा था कि
दोनों को इक्वेट
हियर, एम आई राइट?
यस, तो दोनों वी को इक्वेट करने को.
या सो इसमें क्या होगा, यू सी दिस इज पीएच के इंडिपेंडेंट है. ऐसे भी सोचो कि पीएच के इंडिपेंडेंट होगा तो व्हाट विल हैपन, इट विल नॉट डिपेंड ऑन H प्लस आयन कंसंट्रेशन. इट मींस दैट आपको ये हटाना है, राइट? अब तुम हटा दोगे तो यू विल गेट दिस, एंड सर्टेनली दिस टेल्स यू दैट V डजंट डिपेंड ऑन H प्लस आयन. अब दो स्ट्रेट लाइन है, दोनों का इक्वेशन तुम्हें पता है और तुम्हें इसका इंटरसेप्ट निकालना है. व्हाट यू डू, तभी ये दोनों को इक्वल कर दो. यही करते हैं ना, ये सिंपल मैथ है, isn't it?
सो आई थिंक वहाँ मुझे आवाज नहीं आई थी जो अपने ये वाला दोनों को इक्वेट किया था. तो क्यों कैसे इक्वेट किया वो वाला पार्ट आई थिंक मिस हो गया था.
ये पार्ट है दिस इक्वल टू दिस, ये इस लाइन का इक्वेशन है, राइट?
यस सर.
और ये इस लाइन का इक्वेशन है
इंडिपेंडेंट ऑफ H प्लस.
या सो log V इक्वल है, बट V भी इक्वल होगा. अगर log V इक्वल है V भी इक्वल होगा, am I right?
Yes.
And so I just equated these two. What I got, K2 cancels out, E naught cancels out, S cancels out, Km cancels out. What is left?
Yes.
Kb by H plus is equal to 1.
1.
So Kb is equal to H plus, or H plus is equal to Kb. That's what I have written here. Similarly, in this case, at high pH, you can do same thing. अब यहाँ ये दो इक्वेशन है, this one and this one, right?
Okay,
इन दोनों को
yes,
इक्वेट करो and then you will get H plus is equal to K. That's all. So H plus by K will be equal to 1, and after cancelling things, so H plus is equal to K. Is this okay?
yes, sir. Thank you.
Okay. Any other questions? No? Okay, so I will stop here. In the next question, next class, I will discuss heterogeneous catalysis, and that is the last chapter which I am going to discuss. Okay, 2 or 3 more lectures. Okay, thank you.
Thank you, sir.